What's up, guys? Welcome to day 30. This is the last video before we take our test over implicit differentiation. I'm going to work on problems 3, 6, 7, and 10. So if any of those or all of them are giving you trouble, watch the ones that you need to watch. And just be ready to take this thing tomorrow. Okay, so number 3 says sine of x plus x cubed y squared equals 3. We simply want to find dy dx. So let's take a look at this one. So the first thing I want to do is go through and derive all the terms in the equation, remembering any rules that I need to do. I like to kind of anticipate what rules are coming. Sine x is going to be no problem. X cubed y squared, that's going to be a product rule, because I have a function x cubed times another function y squared. Derivative of 3 is going to be really easy. So here's what I get. Derivative of sine of x is cosine of x. Plus, I have to do the derivative of the first, which is 3x squared, times the second, y squared, plus the first times the derivative of the second. Remembering to tack on dy dx because I did a derivative of a y function, equals 0. So that's how I start this thing. The next thing I want to do is kind of, before I start solving or getting dy dx alone, I just want to reorganize a little bit. The first two terms don't need any reorganizing, but the third term does. And it'll just help us make sure we do this correctly. So I'm going to rewrite this thing as cosine x plus 3x squared y squared plus 2x cubed y dy dx equals 0. So I want to get dy dx alone. So what I'm going to do is I'm going to move the cosine x and the 3x squared y squared to the other side. And I've got 2x cubed y dy dx equals negative cosine x minus 3x squared y squared. Then I'm going to go ahead and divide by 2x cubed y, and I'll get dy dx equals negative cosine x minus 3x squared y squared over 2x cubed y. I'm going to look for anything that I can cancel here, and there's nothing I can. Make sure you don't cancel out that x and the cosine x. That can't be canceled out. It's part of the trig function cosine. That's it for 3. Let's look at 6. So 6 says we have our curve there. We want an equation of the tangent line at the point 1, 5. Anytime I want an equation of a tangent line, I want my point, which I already know is 1, 5. And I need to find the slope, and I need to write my equation. For the slope of the tangent line, obviously I need the derivative, and then I'm going to plug in the 0.15 into my derivative to solve that. Okay? So once again, looking at doing the derivative here, I'm going to see yet again another product rule because of that 2xy. Everything else should be pretty normal. So going ahead and doing the derivative, I'm going to get 4x plus my derivative of 2xy here is my product rule. So I want to do the derivative of the first, which is 2, times the second, which is y, plus the first, 2x, times the derivative of the second, which is dy dx. Right? The derivative of y is 1, but it's 1 times dy dx equals 0. Now I want to reorganize this thing. I want to, nothing really to do in terms of that, so I want to get dy dx alone. So I'm going to subtract 4x and subtract 2y to the other side. So I end up with 2x dy dx equals negative 4x minus 2y. Make sure both of those are negative. Okay? Or they could both be positive and the 2x dy dx could be negative. Either way works. And I get dy dx equals negative 4x minus 2y over 2x. Again, I can look here for simplifications. We don't have to do that. But we do see here that 4, 2, and 2 are all divisible by 2. So if you want, again, you'll get the right answer either way. But if you want, take a second here to reduce this. We can call it negative 2x minus y over x. Might just be a little bit easier to evaluate. Since we're dealing with 2's and 4's, it's not super crucial that you do that. Okay, so that's my derivative. Now I want to evaluate that derivative at the point 1, 5. So all my x's are going to become 1's, all my y's are going to become 5, and I end up with this, negative 2 times 1. Okay, I'm using this to plug in. Negative 2 times 1 minus y, which is 5, all divided by 1. So that gives me negative 7 over 1, which makes negative 7. So my slope is negative 7. Therefore, my equation is y minus 5 equals negative 7 times x minus 1. And I'm done. Let's look at problem 7. Now all I need is the slope of the tangent line at the point negative 3, 4. So I don't have to write the full equation of the line. All I need, I can stop once I get the slope, which means I want to find dy dx and plug in the point negative 3, 4. This one's pretty simple. No product rule, no quotient rule or anything like that. All we have to remember is when we do a derivative of y, we tack on dy dx. So here's what we get. 2x plus 2y dy dx equals 0. No reorganizing to do, so I'm just going to start solving for dy dx. I'm going to get 2y dy dx equals negative 2x. I'm going to divide by 2y, and I'll get dy dx equals negative 2x over 2y. Both of those divide by 2, so I'm going to call it dy dx equals negative x over y. So that's dy dx. Very simple. Now I want to find dy dx at the point negative 3, 4. So I'll say dy dx evaluated at the point negative 3, 4 equals. Now I just got to replace my x with negative 3 and my y with 4. Be careful here, we have negative x, so it's like negative 3 over 4, which makes 3 over 4. And that is my slope of my tangent line at the point negative 3, 4. Last problem that I want to look at is problem 10. Problem 10, we have to find the second derivative, and we want that in terms of x and y. So to get to the second derivative, we're going to end up doing two derivatives here. So the rule that we see right off the bat, I see a 9x and a y squared. That would be the product rule. The derivative of 8 is going to be no problem. So I do the derivative of the first times the second plus the first times the derivative of the second, multiplying by dy dx because I did a derivative of y, and that has to equal 0. I definitely want to do some reorganizing here with that second term. So I'm going to rewrite this thing as 9y squared plus 18xy dy dx equals 0. Again, on your test tomorrow, make sure you take the time to reorganize before you start solving for dy dx. It can help you make avoid errors in simplification. Okay, now I'm going to subtract the 9y squared to the other side, and I'll get 18xy dy dx equals negative 9y squared. Then I want to go ahead and divide by 18xy. Now that is dy dx. But if you do not simplify this, you're going to make your life much, much worse when you try and find the second derivative. This thing simplifies big time. And if you don't make that simplification, again, you're really making it difficult to earn the full credit on this one. I see 9 and 18, they both divide by 9. I also see a y in both the top and the bottom. Okay? So dy dx here is going to simplify, right? That squared is gone, that whole y is gone. That 9 becomes a 1, that 18 becomes a 2, and I end up with negative y over 2x. A much simpler form than negative 9y squared over 18xy. I end up with negative y over 2x. I like to circle my dy dx because I'm going to need to plug that in to be in terms of x and y at the end of this problem. Now I can go through and I'm going to do the derivative again. So I'm going to do the derivative of dy dx. That's my second derivative, that weird notation we have for the second derivative. Equals, when I derive the right side of the equation, I need to use a product rule. Quotient rule. Quotient rule says I do the derivative of the top, which is negative 1 times dy dx. I'll just call it negative dy dx. That's the derivative of the top times the bottom, minus the top times the derivative of the bottom, all over the bottom function squared. Now, before I substitute in that dy dx, I really want to reorganize here. Reorganizing is going to be an important step. I want to write this whole thing just in nice, simple terms. Then I'll plug in later. So negative dy dx times 2x, I'm going to call that negative 2x dy dx. I'm going to now change this to plus 2y, and I'm going to call the bottom 4x squared. Remembering all my exponents. Okay. Again, right now I can take a second to simplify this thing down as well. After I reorganize, this thing does have a simplification. I see 2, 2, and 4. Those all divide by 2. Again, you don't have to make this move, but it might help you. It's not as crucial as the move with the negative 9y squared over 18xy, but it can help. So we'll call this negative x dy dx plus y over 2x squared. Okay, so that's as simplified as I can get for the time being, but I'm still not in terms of x and y. I'm in terms of x and y and dy dx. So I'm going to sub in for my dy dx here. I'm going to look up into what's circled for my dy dx. It's negative y over 2x. That's subbing in right here, right? This becomes this. Plus y over 2x squared. Okay? Now this is kind of a mess, but it is in terms of y and x. Right? If it was free response, we could circle that. I want us to practice simplifying it down because of multiple choice. When I multiply these two terms, my x's cancel each other out. And I get negative 1 times negative y, which is y, over 2. That became positive now because of the negative times the negative. Plus y over 2x squared. To simplify it one more time, I don't like having fractions within fractions, so I'm going to multiply the top and bottom here by 2. And I end up with y plus 2y, right? Make sure you distribute, over 4x squared. Y plus 2y is 3y. So very nicely here, I get my second derivative in its simplest form to be 3y over 4x. I'm done. That's it for today's video. I think I did every problem except for 1 and 2, which were more simple. If you want help with 1 and 2, see me in the morning before we take our test. Study hard, prepare well, remember every rule. Execute every rule to its
fullest extent and ace this thing tomorrow. See you guys. Do change.